Hello, and welcome to Developing for Performance HTTP 2. I'm Morten Rand-Hendriksen, Senior Staff Author and Web Performance Enthusiast, and I'm super excited to take you on a journey through performance enhancement for the new HTTP 2 protocol. For your website to be effective and reach its audience, it has to have a great user experience. Performance plays a big part in this process, and there are tons of best practices out there for how to make your site lightning fast. But there's a hitch. Up until now, we've been working with an old and restrictive HTTP protocol, and most of the performance enhancements we do are targeted at that old protocol. That's all about to change. With HTTP 2, we get new performance enhancements like multiplexing, compressed headers, and server push, all of which will make your site more performant. But a lot of our old performance enhancements work against what HTTP 2 does. This course will show you how to take advantage of what the new protocol has to offer and set up a performant process that produces performant websites. To start off, I'll discuss what performance is, how to measure for it, and how HTTP 2 changes the way we think about communication between the server and the browser. Next, we'll take a close look at how to tame the biggest performance hog out there, images, through advanced image optimization. We'll take a deep dive into code optimization and how to prepare your files for HTTP 2. And finally, we'll look at how to optimize server delivery and browser handling to reach peak performance. Optimizing your sites for performance produces a better user experience, makes them more likely to be found on search engines, and saves both you and your visitors valuable time and data. In short, performance matters, and I'm here to show you how to do it right in an HTTP 2 world. So, let's get cracking with Developing for Performance HTTP 2. This course is intended as an intro to performance optimization with HTTP 2, so if you want to, you can just sit back and watch. Or if you want to follow along with your own code, I've created exercise files for you. To use them, you need a code editor like Atom and a working command line with Node.js support. More on that later in the course. So here's how you use the exercise files. First, download them from the course page and place them somewhere on your computer. You'll get this folder, and inside you have individual folders for each of the movies. Now, not every movie will have exercise files. The files only exist for movies where there's actual code or other assets that you can work with. The majority of examples you'll get in this course rely on command line tools that are powered by NPM or the Node Package Manager. So if you go into, say, 0305, you'll see here we have a grunt file with the grunt tasks, a gulp file with gulp tasks, and package.json. Now, if you want to follow along step by step, here's what I recommend you do. Don't work straight out of the exercise files folder. Instead, create a new folder for yourself, call it something like my project, and then copy the files from the exercise files into the My Projects folder. From here on forward, you'll always be working out of the My Projects folder. Now here's why you want to do this. If you go look at the files in 0305 and in particular package.json, you'll see the project has a set of dev dependencies. These are node modules we need to have installed to be able to run all our processes. We have auto prefixer and grunt and gulp post CSS and gulp web server and so on. Now all these have to be installed into your folder for everything to work properly. And I can't ship these modules because they're gigantic. And if we ship them, you would never be able to install them onto your computer. So you have to install these manually through NPM. Now, once you start off with 0305 and place the files into the My Projects folder, run NPM on all of these different packages to get them installed inside the My Project folder. Then, when you move on to another movie where you have new packages, say 0307, simply copy all the files from 0307 and paste them into the My Projects folder. This will overwrite anything you already have in My Projects, except it will not touch the node modules folder. Then all you have to do to get up to date on the current movie is open package.json, check out if there are any new dependencies, there usually are for each movie, install those through NPM, and you'll be able to keep going. That way you only need to install the node modules once, and you can still use the exercise files as we move forward in the course. So create a new folder for your own project, dump the exercise files for the current movie you're working with into that folder, install the node modules, and you're good to go. Have you ever noticed that when you surf the web, some sites load much quicker than others? Sometimes the site loads immediately as if it was already on your phone and computer, and other times you're left staring at a blank screen for what feels like ages, only to have the site come up in bits and pieces while the content shifts and moves around. This is what we call web performance or page speed, how fast any particular web page loads in your browser. A site that loads quickly has good performance. A site that makes you stare at a white screen for a long time has bad performance. The performance of a site relies on several factors. The visitor's connection speed, which we have no control over. The bandwidth and power of the web server, which we can control by picking the right hosting provider. And how well our site is optimized for performance. That's what we'll focus on in this course. You use the web, so you know that performance matters, but you may be surprised to learn how much it matters. The impact of the performance of a site can be split into 3 categories: user experience, user and owner cost, and findability. User experience first. I'm certain you've abandoned many sites without reading them because they were slow to load or buggy. We all have. Performance has a significant impact on the user experience of a site. Good performance provides a good user experience, and bad performance, a bad one. But performance is more significant than merely having a bad experience. Studies have shown that visitors will abandon a site in as little as 3 seconds if it does not load properly. Studies from online retailers show every second shaved off the load time has a direct positive impact on conversions. In short, improved performance means improved user experience, means improved conversions. Conversely, a site with poor performance is losing you visitors and money every second it does not load properly. Performance also has a direct financial impact on both the people visiting the site and the site owner. The main reason for poor performance is bloat, big image files, big code files, and lots of them. As of July 2016, the average size of a web page is 2.4 megabytes. That means every time you visit a link, you are likely downloading 2.4 megabytes of content, of which only a small fraction actually matters. This number is increasing rapidly, mostly thanks to the proliferation of high-quality, high-bandwidth connections at home, at offices, and through mobile networks. With fast internet, size doesn't seem to matter. But if your internet service is slow, or has a bandwidth limit, or both, it does matter. A lot. Every bit of data costs money, and thus serving up a bloated website is wasting people's money. If people realized how much bandwidth is wasted loading unoptimized and poorly performing sites, there would be complaints. The same can be said for the site owner. If the average size of your web pages is 2.4 megabytes and you get 1,000 visitors, you just pushed 2.4 gigabytes of data through the web. And if each of those visitors loads a couple of pages, that number is multiplied. Most web hosts operate with bandwidth levels, and once you exceed them, you pay a premium. As a result, a poorly performing site can cost you and your company a lot of money over time. Finally, search and findability. For a site to be successful, it has to be findable. That usually means the site needs to be indexed in search engines and shareable through social media. Over the last couple of years, search engines, headed up by Google, have started weighting and ranking sites based on performance. Fast and well-performing sites bubble to the top of the search results, while poorly performing sites drop to the bottom. This is partially a result of their mobile-first strategy, but it's also an attempt to push web developers like you and me to think more about performance. That means if you want your site to be found on search engines, making sure they are optimized for performance is an important step. So, what is performance? In a nutshell, it's how fast and effective your site loads in the visitor's browser. And to build a website with great performance, we need to optimize everything within it, from the images, to the code and other elements, to how they are handled on the server, delivered through the network, and processed by the browser. When building a website, there are many points where its performance can be optimized, and not all of them are directly related to the website itself. We also have to consider different types of performance. There is, of course, technical performance, meaning how long it takes for every asset to be downloaded and displayed correctly in the browser. But there is also perceived performance, how long it takes for the visitor to get a functional experience in the browser. And while technical performance is important, we can greatly improve user experience by also focusing on perceived performance. So, let's consider a standard website and where we can optimize its performance. First off, most websites consist of 4 main components: the HTML markup document, 1 or more CSS documents, 1 or more JavaScript files, and 1 or more images. In addition comes other things like fonts and external embeds and things like that. All of these components can be optimized for better performance. The HTML document can and should, of course, be valid, accessible, and have a logical content structure. This alone will improve its performance. Improvements can also be made by using native browser behaviors as much as possible, like buttons for buttons, lists for lists, select boxes for selects, and so on. And to optimize it further, the document can be minified and compressed, reducing the time it takes to send it from the server to the visitor device. With the style sheets and JavaScript, we can take optimization a step further. In addition to minification and compression, writing dry or don't repeat yourself code, relying on default browser styles and behaviors whenever possible, and serving up critical components to display the content above the fold first before handling the rest of the page will provide dramatic performance improvements. Now, here's something new. With HTTP2, which is the focus of this course, a lot of performance best practices when it comes to CSS and JavaScript are no longer valid. For example, concatenating and crunching all of your CSS into one file and inlining critical CSS is no longer recommended. We have better options for that, which I'll talk about later on in the course. Finally, we have images, the main cause of page bloat and the biggest opportunity for performance optimization. We'll cover image optimization in greater detail later on, but here's a sneak preview. Everything from file format to image quality, to encoding, to compression, to size, to delivery, and display method will have a significant impact on the overall performance of a site. Not to mention always asking the question, will this image help the visitor and improve their user experience? More often than not, the answer is no. With code and images optimized, we can turn our attention to how the files are provided to the visiting browser. Here, everything from compression to loading order to caching to content delivery networks comes into play, all of which we'll discuss in detail. Finally, when the assets reach the browser, we can improve the perceived performance of the site by serving them up top-down, so to speak. Make sure the content above the fold renders first and that all critical elements are available before adding the extra bells and whistles. I know this sounds like a lot of work, but as you'll see, most of these processes can be automated using command line tools, and those who cannot can be greatly simplified by making them part of your regular development process rather than a final step holding up the end of the line. I've structured this course to fall in line with a logical order of how a site is built. This way, each step brings us closer to the final product. In the exercise files, you will find the site I'll be working with, and you can follow along on your own computer to get the full experience. Be advised, I'll use the command line task runner Gulp as well as a node package manager extensively throughout the course, so if you're unfamiliar with these tools, I recommend checking out Ray Vigilobos' courses Post CSS First Look and Up and Running with NPM, the node package manager. Here's how the course breaks down. In Chapter 2, we'll take a closer look at how browsers render content, what HTTP2 is, different tools for measuring site performance, and discuss the concept of performance budgets. In Chapter 3, we'll take a deep dive into optimizing graphics, images, and fonts for performance, and I'll introduce you to tools and techniques to automate this process as much as possible. In Chapter 4, we'll focus on optimizing code, HTML, CSS, and JavaScript. I'll show you different tools you can use to automate your development process and generate optimized code. We'll discuss how HTTP2 changes the way we deliver CSS and JavaScript for optimal performance, and I'll give you some tips on how to create a critical rendering path for your pages. In Chapter 5, we'll move on to the delivery of the content. Here, we'll look at data compression, caching and cache management, a new HTTP 2 feature called Server Push, and discuss the advantages of offloading the heavy lifting to a CDN. And finally, in Chapter 6, I'll discuss some strategies for making performance part of your process and getting everyone on your team or organization on board with making performant websites. Are you ready? Because this is going to be a wild ride. To understand performance optimization, we first have to understand how browsers render content, so let's break that down. When you tell the browser to load up the contents of a web page, this is what happens in an extremely simplified way. First, the browser receives an HTML document and starts reading it from the top. It creates what's known as the Document Object Model, or DOM. Then, when the browser encounters a CSS file, typically towards the top of the page inside a link element, it stops rendering the page until the CSS file is fully loaded. This will happen for every single CSS reference in the head of the page. It creates what's known as the CSS Object Model, or CSSOM. If the browser encounters a JavaScript file, it assumes there will be relevant CSS or HTML, and it makes sure that all of that is loaded before the page is rendered. This operation varies greatly depending on the browser the visitor is using. Only once all the assets are in place, the browser paints the page and we get the output on the screen. Of course, this is way more complex in real life, but for our purposes, this explanation is good enough. What matters in relation to performance is the blocking behavior around CSS and JavaScript. First of all, if you have a document with a lot of CSS, either in one huge file or in many smaller files, the page will not be rendered until all that CSS is downloaded. And that means a significant delay. Secondly, if your page layout or behavior relies on JavaScript, the visitor has to wait for everything to get loaded in the right order before anything will work. This is further complicated by the way the HTTP protocol works, or at least how it worked in HTTP version 1.1. You see, in HTTP 1.1, the browser can only queue up one HTTP request and pull down one file at a time. So first, the HTML file. Then the first CSS file, then the second CSS file, then the first image, then the second image, then the third image, then the first JavaScript file, then the second JavaScript file, and only then can the page be fully rendered. This is crazy slow, so slow in fact that browsers have resorted to cheating. They open up as much as 6 parallel connections to bring down as many files as possible at one time, but this often causes head-of-line blocking, meaning the file at the head of the line blocks everything else, and it's a massive tax on the browser, the network, and the server. As sites become more and more CSS and JavaScript heavy, this becomes more and more of a problem, and we've developed some pretty clever workarounds to deal with it. For CSS, a common recommendation is to inline critical style rules in the top of the HTML page and let that section be rendered before any external style sheets are loaded and the browser is blocked. For JavaScript, we typically call them at the very bottom of the page after everything is done to avoid conflict. And for both CSS and JavaScript, we concatenate them, stuffing many files into a single huge file to reduce the number of HTTP request connections necessary to bring everything down to the browser. This situation is, at best, suboptimal. Fortunately, HTTP 2 is about to solve many of these issues. HTTP version 2 is the new protocol that takes over after HTTP 1.1. It started out as an experiment at Google called Speedy that was so successful it grew into the next official HTTP protocol. HTTP 2 is now supported by 76% of global web browser usage, and web hosting companies are rapidly deploying support as well, meaning it is quickly becoming the standard protocol for web traffic. To take advantage of HTTP 2 on your site, 3 requirements need to be met. First, your server must support HTTP 2 and all its features. Second, the connection between the server and the browser must be encrypted through SSL, so starting with HTTPS. And third, the browser must support HTTP 2, which almost all browsers do. If any one of these 3 requirements fails, the connection will be an HTTP 1.1 connection instead. The second requirement, that the connection must be encrypted, is quite revolutionary in its own right. Mandating encryption for performance will make people and companies who previously saw encryption as an unnecessary or complicated add-on reconsider, and as a result, we'll get a more secure and more performant web. It's a win-win situation. Add to this free SSL certificate services like OpenSSL and Let's Encrypt, and you really have no excuse not to slap that S on the end of your HTTP. But that's a bit of a side note. Back to performance. To ensure stability on the web, HTTP 2 extends existing functionality in HTTP 1.1, meaning if a server or browser does not support version 2 or you don't have an SSL connection, the site will just fall back to the older protocol without anything breaking. All this means at this moment we are entering an HTTP 2 world, and a lot of what we know about performance is about to change. Speedy, and eventually HTTP 2, was introduced specifically to deal with performance issues like the ones described in the previous movie. This also means many of the workarounds and patches we've created to deal with those performance issues are no longer necessary, and in some cases, they're actually becoming counterproductive. HTTP 2 comes with a long list of performance enhancements, some of which are automatic, and some we can take advantage of, and in this course we'll focus on the latter group, starting with multiplexing. Whereas HTTP 1.1 allowed only one request to be processed at a time through a connection, HTTP 2 allows what's known as multiplexing and does so in a dynamic way. This means the browser can request and receive many different files at the same time and doesn't have to wait for one file to finish before starting the download of the next one. This in turn means concatenating CSS and JavaScript files and spriting image files to speed up downloads by reducing HTTP requests no longer makes any sense. Rather than piling everything into one huge file, we can now download several smaller files simultaneously. This is both quicker and more efficient because instead of loading all the concatenated CSS and JavaScript on one page, we can load only the CSS and JavaScript required for the current page, saving bandwidth and time in the process. Splitting our files up like this also has other benefits. Each file can be independently cached by the browser for a quick recall. A small update to a style rule or script doesn't require a complete reload of all the styles or JavaScript, and we can even proactively push dependent files to the browser cache before it even knows it needs them. We'll cover all of this and a lot more in the following chapters. Long story short, HTTP 2 changes everything. To demonstrate the tips and tricks I'll show you in this course, I've created an example project and set up two sites on the same server. One at the start of the course, where we are right now, so unoptimized. The other at the end of the project, so fully optimized for HTTP 2. The server I'm using is a standard shared host where I have limited control. It's not particularly fast or particularly powerful, but it has full support for HTTP 2 and its features. When I load up each of these two sites in my browser, you'll notice the optimized one is slightly faster, but the real difference happens behind the scenes. If we inspect the actual network traffic on the two sites, you'll see what I explained in the previous movies. On the unoptimized site, seen here on the left-hand side, the browser first downloads the main HTML document, then opens as many TCP connections as possible and tries to pull down as many CSS files, JavaScript files, and images as possible, all at the same time. When it can't open any more connections, we get this stretched out waterfall effect. Things eventually appear in the browser, but it takes a lot of time and there's a lot of blockages along the way. By contrast, the optimized site running under SSL and leveraging HTTP 2 is a completely different story. Here, the main HTML document is loaded, and while that happens, the server pushes the critical CSS, JavaScript, and image files to complete the first paint. And when the browser encounters new elements to be downloaded, it does so in parallel, bringing down many files at the same time over one TCP connection. The result is a faster load that's far more efficient on the server and the browser. Now, when you compare these two views, you'll see they are fundamentally different. Here on the left-hand side, you see there's a lot of empty space where the browser is simply waiting for the connection to open to call the next files. And what you'll notice is this server is pretty slow because all this green you're seeing here is actually just a server waiting to send content. However, if we look at the stats on the bottom of the screen, the story is pretty clear. The load time for the unoptimized site is 3.39 seconds, and the load time for the optimized site is 1.88 seconds. So there's a significant benefit to optimizing the site. Furthermore, on the front end, when I load the unoptimized site, you can see it takes a while for the browser to paint all the content, whereas on the optimized site, all the content is painted almost immediately. Now, all of this happens on a really basic site, and with a more advanced and more complex site, these benefits that you get from optimizing will be far greater. Regardless, what you see here is the project we'll be working with for the rest of the course. And as we move through the course, I'll start out with the unoptimized site and walk through all the optimization steps that were employed in the final example. The technical performance of a site can be measured using a variety of tools, the most popular of which are online services. These tools all work pretty much the same way. They access your site using a predefined virtual browser and measure the performance of the website, its contents, and the server it sits on. Each of these services paints a slightly different picture of the overall performance of your site, with emphasis on different attributes. So I find the best method for measuring the true performance of a site is running it through several different services and comparing the data. Now, this course isn't about performance testing, but performance techniques. Even so, the best way to check that your performance optimizations meet or exceed benchmarks is to run ongoing tests. Let me quickly show you my favorite tools and how our unoptimized site rates on each of them. First up is Google PageSpeed. It comes in two flavors, the visually stunning and interactive Test My Site from Think with Google, and the old but functional PageSpeed Insights from Google developers. They're actually the same exact tool, just two very different presentational layers. Google PageSpeed tells you how Google ranks your site for speed and performance on both mobile and desktop and scores your optimization efforts based on various factors. Where your site falls short, like on the speed section here, detailed information on how to make improvements is provided. Google PageSpeed is kind of the gold standard for performance because Google now ranks and weights sites based on their mobile performance. That means you need to have a good score here to be discovered on Google. And as you can see, we have a bit of work to do because our current score is 71 out of 100 on speed. Next up, the aptly named Web Page Test. This service provides you a letter-based score for 6 performance factors. First, byte time, keep alive enabled, compress transfer, compress images, cache static content, and effective use of CDN. And you can see right now, I'm only getting an A on 2 of them. The rest I'm getting an F on, or an X, meaning it doesn't even exist. Web Page Test gives you in-depth analytics, like a detailed waterfall view that breaks down all the different pieces of your site and shows all your connections, and a content breakdown that shows you exactly where your biggest data and time hogs are. Hint, hint, on this site, it's images at 95.1% of the bytes transferred. Web Page Test also allows you to run a visual comparison between sites, for example, putting an unoptimized and an optimized version of the same site side by side, as I've done here. And at the top here, we have this film strip view where you see the site is being loaded over time. And as you can see, between the unoptimized and the optimized site, there's a significant difference. At 1.5 seconds, the unoptimized site is loading the text content, but not the main content, but the optimized site is loading the content at the top. And at 2 seconds, you can see there's still a lot of content missing under unoptimized, but the optimized site seems to be complete. And this is what I was talking about before, about perceived performance. When we do this side-by-side comparison, you also get this onion-skinned display of the waterfall. And you can use a toggle up here to toggle between the optimized and the unoptimized view. And here again, you see what I talked about in the previous movie, that in the unoptimized version, so HTTP 1.1, we're getting this very skewed waterfall that leans to the right-hand side, whereas in the optimized version, almost everything is downloaded at the same time. And the only thing that's delaying the site is my server, which is pretty slow. Web Page Test is typically used as the independent go-to reference for objective performance data. 2 other tools I like to use come from Pingdom and GTmetrix. They both provide detailed performance breakdowns with slightly different data and results. So here you can see on Pingdom, we have a page size of 2.8 megabytes and a performance grade of 87. On GTmetrix, we have a page size of 2.73 megabytes and a page score of 87 and a Y-slow score of 84. What you'll notice when you compare the data from all these different tools is that they will agree on a lot of things, but they do not agree on everything. In particular, the load times will be different across the services, and they will provide different suggestions for how to optimize your site further. Additionally, none of these tools are fully up to date on HTTP2 tools and techniques like server push and loading multiple small files instead of one big one. So they may give poor performance grades for techniques that actually speed up your site. This is likely to change as HTTP2 and these new techniques becomes more commonplace. So test your site rigorously against all these tools and optimize your site for performance, even if it means the tools say you are doing something wrong. In the end, it's the total load speed that matters, and if the speed goes up, it means your site is performing better. Images make a website look great. However, that visual appeal comes at a significant cost. Image files can easily become huge, and huge files take a lot of bandwidth and a long time to download. As I mentioned earlier in the course, the average web page is now 2.4 megabytes, and images take up 1.5 of those megabytes. That is 62.5% of the total page size. And it means the page size can be more than halved by simply eliminating the images. It also means if we're smart about how we create, deploy, and use our images, we can drastically improve the performance of our site. So why are images such performance hogs? The answer has to do with the evolution of technologies. To put it bluntly, if you have one of those fancy smartphones with a high-resolution display, you are to blame. I am too. You see, these high-resolution displays require high-resolution images, and to ensure our images are crystal clear, we have to add images with 2x or even 4x resolution, and that means much bigger files with much more data. The good news is we can counteract this bloat with various tools. First off, we can choose the right image format for the right circumstance. Not every image needs or should be a high-resolution JPEG. Second, images can be optimized during creation, saving, and when they are added to a project. In some cases, this requires technical skill. In others, it can be done automatically. Third, thanks to responsive images, we can now serve up appropriate image sizes and resolutions based on the device screen size being used to access the site. This can drastically reduce the total data download, but it can also increase it under certain circumstances, so it's a bit of a mixed blessing. Finally, we can get the browser to generate images for us by providing them as code and markup rather than bitmaps. This is what SVGs are for. But before we do any of this, let me be absolutely clear about one thing. The reason sites are so huge these days is because they tend to have a ton of unnecessary images, typically hiding inside sliders like the one I have on the example site. Whenever you design or build a site and you feel like adding an image, ask yourself if doing so will benefit or help the visitor. If an image or a slider is there just to make things look fancy or for show, take a moment to consider what's more important, having the image there or having the page load faster. In almost every case, it's the latter. In my book, speed trumps more images every time. Thanks to the advancement of web technologies, we now have a good selection of image formats to choose from, and there are more formats on the horizon. When selecting a graphic or image to be displayed on your site, picking the right format can have a significant impact on performance. As of right now, there are 4 formats that work across most browsers and have proper fallbacks for those browsers that lack support. They are GIF, JPEG, PNG, and SVG. Each of these formats have benefits and drawbacks, and each have their ideal uses. Let's take a look. GIF is a bitmap format that creates low-resolution images with a very small file size. In the past, they were used to create icons, but nowadays you mostly see them in popular animated GIF memes. To be honest, I thought GIFs would fall by the wayside a long time ago, but the animated memes have brought them back with a vengeance. When should you use GIFs? In my opinion, never. They're crusty, they're poor quality, and we have a better option in SVG. But that's just my opinion. If you like them, use them. GIFs will never really negatively impact the performance of your site. Next up, JPEGs. This is the most prevalent image format on the web, and for good reason. JPEG compression is great for reducing file size of photos without much of a visual impact. JPEG compression is incredibly advanced and improves all the time, and when you create a JPEG, you can balance file size and visual effect with ease. On the downside, JPEG compression is lossy, meaning as you increase compression, image quality is reduced dramatically. When should you use JPEGs? Anytime you're working with a photo or other complex graphic with a lot of variance. Advancements in progressive JPEGs are making this format better and better for the web, but it has significant drawbacks like lack of transparency. Third, we have the PNG. Like JPEG and GIF, it's a bitmap format, but it works differently. PNGs feature lossless compression, meaning you won't get that weird crusty feel you often see in overcompressed JPEGs. That also means complex PNGs can be quite large in file size, so that has to be taken into consideration. When should you use PNGs? Anytime you're working with a computer-generated graphic or a graphic that requires transparency. When saving your PNGs in the graphic design application, experiment with different settings to find a sweet spot between quality, number of available colors, and file size. Photoshop does an excellent job at this out of the box. Finally, we have SVG or Scalable Vector Graphics. SVG has been around for a long time, but is only becoming mainstream now, largely thanks to the need for, scalable vector graphics. Unlike the three other formats, SVGs are not image bitmaps, but rather web documents that use code to instruct the browser to draw the graphic on the fly. This means they're much smaller in file size and can be manipulated using CSS and JavaScript right in the browser. When should you use SVGs? Anytime you have a computer-generated graphic like a logo or icon or something drawn in Illustrator or another vector program. They add a whole new level of opportunity and interactivity to your graphics, but it comes at a cost. SVGs are not fully supported across all browsers, so you need to provide a PNG fallback to ensure everyone sees your graphic. More on that at the end of this chapter. So here's the breakdown for what image format to use when. GIFs? Never, or if you must, in animated GIFs. JPEG, anytime you have a photo or complex graphic. PNG, static computer-generated graphics that can't be made into SVGs. And finally, SVG, anytime you have a computer-generated graphic. Optimizing images for the web can be done manually, or you can automate the process using command line and other tools. However, for best optimization results, it's a good idea to combine manual and automated processes. For manual image optimization of JPEGs in particular, you can go through a 4-step process. First, blur unnecessary areas by introducing high bokeh or shallow depth of field, and make sure that unnecessary components are removed from the image to make it as uncomplex as possible. Next, size the image to match the largest possible area it will be displayed in on the final site. Here you also have to take into account high-resolution displays, so you have to size it for 2x, 3x, and maybe even 4x displays. Third, export the image with as low quality as possible as long as you are not losing visual acuity or quality. This can be done using Photoshop's Export Manager, where you can sit and toggle the quality output and see what happens when you reduce the quality. Just keep in mind, if you reduce the quality enough in an image, it will look really crusty, so you have to kind of slide that bar for each individual image. And finally, even after exporting an optimized image out of Photoshop or your other image editing tools, you can gain extra performance by running it through an automated optimization tool, either on the web or through the command line. The number one rule of JPEG compression is the more details the image contains, the larger the file gets. In other words, an image with a low depth of field or high bokeh will produce a smaller file size. This means when you take pictures, make sure there are no distracting elements in the background that add extra detail that you don't need, and make sure you use a high quality camera with a good fast or long lens, or maybe hire someone to take the pictures for you. The result will be better optimized images right out of the box. And to show you what I'm talking about, I've taken a couple of pictures and sized them out. So here are 2 pictures from my garden. These pictures were taken pretty much at the same time with the same camera on a stand, and the only difference is the depth of field. On the left-hand side, you see an image with a deep depth of field. So you see there's a lot of detail in the image. On the right-hand side, you have an image with shallow depth of field. Now, right now, these images are straight off my camera, and my camera does zero optimization. It tries to save as much data as possible. If you just take the images and dump them into Photoshop and hit Ctrl or Command S and save them, Photoshop automatically optimizes these images. And you can see for the original image with deep depth of field, we've already lost over 2,000 kilobytes by just optimizing it straight through Photoshop. We can now take things a step further and reduce the output quality of the image in Photoshop by saying export it at 50%. The result now is for the deep depth of field image, we went from 5,805 kilobytes to 804 kilobytes. So we cut off 5,001 kilobytes by exporting it at 50%. And for the shallow depth of field image, the optimization is even greater. We went from 3,689 kilobytes to 258. Now here's the thing. These images right now are gigantic. They are huge images that are meant for print displays, not for display on the web. So if you take the same images and resize them to 1600 pixel width, which is the max size they're going to be displayed at, you'll see the image on the left with a deep depth of field starts out at 579K, and after running it through an online compressor called compressor.io, we get down to 304K, whereas the shallow depth of field image starts out at 248K and ends up at 114 kilobytes. So here you can see, if you start out with an image straight off a camera with a deep depth of field, you started out at 5,800 kilobytes. But if you optimize the image by going through the process I listed out, take a good image, blur out the details, size it to fit the display, compress it, and compress it again, you end up with 114K instead. That is a reduction for one image of over 5.7 megabytes. So as you can see, manual optimization of your images does have a tremendous impact on your website's performance. All right, time to dive into some code. In the exercise files for this movie, 0304, you'll find the unoptimized version of the example site. I have it open in Atom, and I'm using the Atom Live Server package to preview it in my browser. What you notice right away is this page has a lot of images displayed at different sizes. And since it's responsive, the way these images are displayed changes depending on the width of the viewport. Part of our image optimization process is to provide the browser with the most appropriate image sizes based on the viewport of the current browser. This is what RICG responsive images are for. If this is the first time you've heard of RICG responsive images, I recommend you watch my course on responsive images right here in the library. The gist of it is this. When the page loads in the browser knows how wide its viewport is, and it looks for responsive images markup in the form of an image element with the source set and sizes attributes for guidance on what image file it should display for the current viewport width. What you see here is that exact markup. If the images are marked up like this, the browser will download only the image file necessary for the current viewport width and resolution. No more, no less. So as an example, if the viewport width is 400 pixels on a 1x screen, and there is a 400 pixel wide image available, the browser uses this image. When the viewport widens, the browser downloads the next image up, in this case an 800 pixel wide image, and uses it instead. All this happens automatically without the visitor even noticing. The performance enhancements here are obvious. If you visit the site with a small screen or small window, you download a smaller image file. However, if your small screen has high resolution, say 3x or 4x or even 5x, you'll still download the largest image size possible. This is one of the problems with responsive images. Okay, so let's take a closer look at what this actually looks like on the back end. Here you see the markup for the slider at the top of the page, and the first image is marked up like a traditional image. Here you see an image element that contains a source attribute that points at the image, and then we have the alt text for alternative text. In this case, the image is purely for decoration, so the alt text is empty. Now this will serve up the same image regardless of the width and resolution of the screen. Below, we have an image marked up for responsive images. And here you see the image element has a source attribute that points at the smallest possible image. And then it also has the source set attribute that points at a series of different sized images. So here we have one image sized 400 pixels wide, one sized 800 pixels wide, and one sized 1600 pixels wide. And at the end of each of these declarations, we have this width attribute that tells the browser exactly how wide these images are. Then below the source set attribute, we have the sizes attribute that uses media queries to tell the browser what size the image will be displayed at different viewport widths. So in our example, this is really easy. If the max width of the viewport is 400 pixels, we want to use the image that is 400 pixels wide. That would be this one up here at the top. If the max width of the browser is 800 pixels, meaning it's between 400 and 800 pixels, then the image will be displayed at 800 pixels, so we'll use the second image. And for all other cases, we will use the third image, the one that's 1600 pixels wide. Now, how did I get to these sizes? Well, through experimentation. You literally put the images into the page and measure how wide the widest image is going to be when it's displayed. And in my layout, the images never display at anything wider than 800 pixels, so I feel pretty safe in providing that 800 pixels wide image as the widest image. Now, if you look closely at my code, you'll notice that the slider at the top has images that are 1600 pixels wide, but if I scroll down further, the rest of the images are maxing out at 800 pixels. And you may wonder why I want to do that, because as you can see, these images might easily, on a 2x or 3x monitor, require bigger sizes. Well, the answer is quite simple. I don't necessarily want to provide gigantic images, even if it means they'll be slightly blurry. So I'm trying to optimize the site by not jamming in a ton of huge images. The reason why I have the top images set at 1600 pixels is because if I widen the screen here, you'll see this top image is full bleed. And that means if you're on a gigantic monitor and your browser is spanning the entire width of the monitor, then the images will get really blurry if they're only 800 pixels wide. So for that particular instance, I've set up a separate image size that's 1600 pixels wide. So now I need to convert my traditional old image element into a new modern responsive images element. And I can do that manually by simply copying and pasting a bit of code here. So if we look in the images folder, you'll see here in main promo, I have a bunch of different image sizes, and we're looking at the one that's called Welcome 01. Here you see we have Welcome 01 400, 800, and 1600 already available. I've also added in the original file, which is even larger than that, so you can take a look at it if you want to. So now I can go into index.html and update my code. I'll simply copy out the existing code for one of the other responsive images, paste it in, and then just make changes to the original files. Now I know you're going to ask, where did these images come from? And the sad answer is, I actually generated them manually in Photoshop by setting up a Photoshop action. There are some command line tools that allow you to kind of automate the process of generating different sizes for responsive images, but I've tested them and they're really clunky to work with, especially if you have a lot of different types of image sizes. So I actually find for custom hard-coded builds like this example, that generating them manually from Photoshop works better. That said, if you're using a content management tool like WordPress or any other content management system, all of these applications generate responsive images code on the fly and will generate all these image sizes for you. So this manual process of creating each individual image size and then putting in all of this code manually only really kicks in if you are building a custom bespoke site by hand. I'm only doing it here to show you exactly what happens when we create responsive images. So now that you've seen it, go through the code in this example in the exercise files for this movie and really figure out how this all works. Also, try to see what happens if you swap out some of the image files or if you take some of these away. Look at what happens in the browser, look at what files are being downloaded at different browser widths, and you'll see responsive images working effectively in your browser. At this stage in the course, we'll start automating the optimization of our project using command line tools, so I'm taking this short sidebar to show you how everything is wired up as we get started. In the exercise files for this and many of the following movies, you'll find the same files I'm working with. Though this is more of a high-level course teaching you concepts, you can play along if you want. To do so, you need to install the various npm packages used in the project. They're all defined inside package.json, and you'll notice as we progress through the rest of the course, I'll add more packages to the project. These packages are not shipped with the exercise files because, quite frankly, they're way too big to ship. I'll be using Gulp as my task runner for this project. If you're unfamiliar with Gulp or NPM or task runners in general, I suggest you check out Ray Vigilobos' 2 courses, Post CSS First Look and Up and Running with NPM the Node Package Manager before continuing. These 2 courses will pretty much explain exactly what's going on in this course. So if you need a refresher or you need to kind of put the pieces together, go check out Ray's courses, then come back here and continue. What you see in the following movies will work on both Windows and Mac, but if you're on Windows like me, you need to install Node.js and also install the Gulp npm package globally to get everything to work. In the exercise files for this movie, 0305, you'll find 3 folders and 3 files. We have package.json, which is the standard npm package file that sets up everything. We have a grunt file that I'll address later on in this chapter. And we have the gulp file that sets up the gulp processes. And that's what we'll focus on in this movie. Before we do so, let me just address the 3 other folders. Now, Node modules is the folder that contains our Node modules. When you install them, they all dump in there, and that's the folder I'm not sharing in the exercise files. So we'll just ignore that one. What we have instead are these 2, development and production. And if we look at them right now, you'll see they look pretty much the same. So what happens here is, as I work through the project, I work in the development folder. Then Gulp monitors the development folder for any changes. And whenever changes occur in the right types of files or in the right folders, those changes are automatically processed and put into the production folder. So the production folder contains the final product that will ship to the server. And as we move further along in the course, you'll see the contents in the production folder will start changing from what we have in the development folder. That's the entire point. So let's look at this Gulp file that makes all these things happen. In the Gulp file, I've set up some standard Gulp processes. We start by calling in Gulp, then a web server to run an automated web server so we can see what we're doing on the web. We have Post CSS, which kind of works like Sass and Less, only it happens at a different stage. And with Post CSS, I'm using auto prefixer to add prefixes to things like Flexbox, and also pre-CSS so I can introduce things like variables and other components that are common in Sass and Less. And finally, I define 2 folders. A source folder, development, and a destination folder, production. These are just variables I can use later on. I've set up a series of Gulp tasks, and right now they're not really doing much. Here we have an HTML task that just monitors all HTML files. Anytime they change, it puts the new version into the production folder. Then we have a JavaScript task that does the same. It monitors all the files inside the JS folder and puts them into a new JS folder. And I have a separate task for the files that are inside JS/libs. So these are the library files like jQuery or other things that I don't want to change later on. So I'm basically setting up 2 Gulp pipes here so I can process some JavaScript files and ignore others. The CSS task is already kind of built out, and here you can see for each of the CSS files, we are running it through Post CSS, then pre-CSS, and auto prefixer before putting it into the production folder. And finally, we have the watch task that watches everything. So it watches for changes in HTML, JavaScript, and CSS. If any of those changes occur, we run all the other tasks, and then we set up the web server to reload so we can see what's going on. At the very bottom, we have the default task that just runs all these processes in turn and then sits there and watches what happens. So this is a really straightforward standard Gulp file. And as we move forward in the course, you'll see me changing this Gulp file to just add more tasks. And I'll also augment the existing tasks that are already here. Now, as you can see, only one of these tasks is really doing something right now. It's the CSS task. So let's take a closer look at exactly what's happening here. If we go to the development folder and go to style-main.css, you'll notice at the top, we have an @import for a file called variables, but it doesn't have a suffix on it. And at the very bottom of this file, we have more imports for a bunch of other files. That's because my CSS is currently modularized. So style-main.css currently only contains reset and some core styling, including typography. The rest is modularized into different components here. And as you can see, the file names here are structured pretty much the same way you would structure file names for Sass. Now, post CSS and pre-CSS work together to make all this stuff work pretty much as Sass. So if we look at variables.css, you'll see here I've set up variables, navy, lilac, red, and beige. And because I'm running everything through post CSS and pre CSS, I can use these variables in any of these CSS files, and the colors will automatically be inserted. For any of the other files, they're just standard CSS files with some nesting and some other components in them. And all of this gets combined into style_main.css. So in production, style_main.css, all of these styles have been crunched into one file. This is how we used to do it with HTTP 1.1, and you'll see later on in the course that I'll actually separate all of these components out and handle them as individual files. All right, before we wrap up this movie, let me just show you what happens when I run this Gulp task. So I'll go to my command line or to terminal and type in Gulp. And I like to run Gulp in verbose mode so I can see what's happening. So I'll say -- verbose. Run the task. The live web server opens and spins up and gives us the contents of the site. And if you look at the verbose output, you'll see here we start and stop HTML, JavaScript, CSS, watch, web server, and everything else. And if I now go in and make a change, let's say to style main, I'll add a space here and click save. The CSS task runs again. So now Gulp is running properly, and we can make changes to our files, and they automatically get processed into the production folder, and that gets displayed in the browser. That means we are ready to start optimizing. By now you know how important image optimization is for performance, and you also know how to manually optimize your images. But we can take this a step further by using command line tools to optimize the images on the fly. If you look at the exercise files for this movie, 0306, you will find that in the development folder, we have a folder called images that contains 3 new folders: experience, main promo, and testimonials. And inside each of these folders, there are all the files for our responsive images. So we have the original file, we have the 1600 width, the 800 width, and the 400 width. Now these have all been optimized through Photoshop already. The next step is to optimize them through command line tools to make the files even smaller. What I want to end up with is a situation where anytime I add a new image into any folder inside the images folder, or add a new folder inside the images folder, the process automatically optimizes those images and dumps them into the production folder under images. So as you can see right now, under images in the production folder, I only have a square background SVG. I don't have these 3 folders. So if my process works properly, I'll get all of these folders into the new images folder in production, and I'll get the optimized version of all of these images. This can be achieved using a variety of different tools. The ones I find most helpful are these 2. Gulp Image, which is an extremely aggressive optimizer, and Gulp Image Min, which is a little more careful with the images. So the difference between the 2 has to do with how much compression happens. With Gulp Image, you get the most optimization I've ever seen out of any application, but it comes at the cost of color depth. So the images get a little dull when you run them through this process. That means if you really care about the color depth, let's say you're building a website for a photographer or artist or someone else who really cares about the colors, you might want to try out Gulp Image Min instead, or do a side-by-side comparison to see what actually happens to the images once they get optimized. Both of these options optimize PNGs, JPEGs, GIFs, and SVGs. You just specify which files you want to run through the process, and then it'll automatically do it for you. They also have some variables that you can tweak and mess around with if you want to, but for the most part, you just want to run them straight out of the box as they are. So let me show you how this works. I'm going to use Gulp Image to optimize all of my images on the fly. It starts with installing the package, and I can do that from the command line by typing in npm install, and then Gulp Image, save dev. Now, I'm not going to do that right now because it takes a long time. It's a huge package. But if you run this, you'll see it runs through a bunch of tests, and then it'll be available in your application. Once installed, I want to make sure it's actually there. So I'll go to package.json and just check that Gulp Image is now referenced. That means I have it in my application and I can start working with it. Now I need to set up my Gulp process, and it starts by giving Gulp Image a name. So I'll give it a variable name, image equals require Gulp Image. That way, whenever I call image as a function, it'll actually call Gulp Image. Then I can set up the task. So here I'll give myself some space, optimize images through Gulp Image. Then I'll set up the task itself, Gulp task, I'll give it the name image optim. And inside the task, I have a function. End the whole thing with a semicolon, and then we can start defining what happens. So first, we want to grab all the images inside the images folder and any subfolder within that folder. So I'll say gulp source, which you remember is the development folder, plus the images folder, and then any folder, and then any file with the extensions JPEG or JPEG uppercase. Now, like I said, Gulp image will optimize PNGs, JPEGs, GIFs, and SVGs if you want them to. The way to do that is to simply add the extra suffixes in this array. So if I wanted to optimize PNGs, I would just say PNG here, and then that would happen as well. But for now, I only want to optimize my JPEGs. Now that I have the images, I need to run each of them through Gulp image. And I do that by setting up a pipe. And in the pipe, I put in image. Now this is the name of the function. So here, image points at Gulp image, and here I call image. Then, once the images have been optimized, I need to place them somewhere, and I'll set up a new pipe for that. Inside the pipe, I use the Gulp dest folder to say this is the destination we're going to put the files, and I'm going to point to dest, which is the production folder, plus images. This will place the optimized images inside the images folder in the production folder, and hopefully it'll preserve the folder structure as well. So now I can save gulpfile.js and run a test on it to make sure it works properly. To do so, I'll run just the new image optim function in command line. So I'll say gulp image optim and see what happens. Now image optim runs through each individual image, optimizes it, and spits it out into the correct folder. So if I go in here and open images, you'll see here we have the same structure. And if you look at the output in the command line, you'll see that each of these images have been optimized. So here, for instance, the earth.jpg file has been optimized by 60.9%, and 60.9, 55.9. So this is a fairly aggressive optimization that truly reduces the file size of each of the images. Now that I know the function works, I need to set it up so that anytime we add a new image or make some changes to images, this process runs again. So I'll scroll further down in my Gulp file until I find watch. Here, I'll add a new line, gulp, watch, source, plus, and here I want the images folder. So again, images. And once I have the files, I want to run image optim on them. So you'll notice this syntax here is the same with all the different watch tasks. You simply copy out the watch task and paste it down. Now, the final thing I want to do is make sure that image optim runs immediately when we start our gulp task. So I'll put image optim into our default task as well. And now I can save my gulp file and try to run gulp and see what happens. So I'll just run gulp, verbose. Here, the live preview web browser spins up and shows images, meaning they are at least working. And if I look at the output, we have run another optimization of the images. Now you'll remember, this is the optimization from development into production, and this will happen anytime we make a change. So if I now add a new image into the images folder, the whole process will run again, we'll re-optimize all the images, and we'll get the output we want. If you're going to display computer-generated graphics, such as the logo you see up here at the top in the header, or icons or something else, consider using SVGs, or Scalable Vector Graphics. These files allow for a level of quality and customization previously only dreamed of on the web. The immediately obvious benefit of SVGs is they're generated on the fly by the browser, so they can be scaled to fit any display and will always appear crisp and clear in any size and any resolution. In addition, they're extremely performant because they're tiny little XML files, and because SVGs are code-based, they can be styled using CSS and manipulated using JavaScript. To get the full benefit from SVGs, they have to be displayed as inline elements, as you can see here in the code inspector. And that makes them a bit of a pain to work with, because you basically have to put these gigantic code files into the markup of your HTML documents. Fortunately, the clever minds at Filament Group have created a command line tool called Grunticon that automates optimization while simplifying the inlining of SVGs and providing robust fallback for older browsers. In the exercise files for this movie, 0307, you'll find gruntfile.js containing a fully built-out grunt task for Grunticon that grabs any SVG added to the graphics folder in development and generates all the necessary code to display full backwards compatible inline SVGs on the front end. Under the production folder, you'll see that in the graphics folder, we have a completely different setup. Here we have fallback PNGs, and we have all the different Grunticon elements. In the example project, SVGs generated by Grunticon are displayed in the header as the logo, and also in the footer as social media icons. This all works thanks to a clever piece of JavaScript that sits in the header of index.html up here and monitors the abilities of the browser. If the browser supports SVGs, the script scrubs through the HTML, finds any element that has the data Grunticon embed attribute assigned to it, and replaces its contents with an inline SVG. Now, here's a little optimization trick. You see, the problem with this particular approach in Grunticon is the SVG will only be displayed once the JavaScript for Grunticon runs and all the necessary files get loaded. And if you're on a slower server, that may take a few seconds. And that means if you're using an icon at the top end of the site or somewhere around the top of the fold, then you might not see the icon immediately. There's a workaround here because of how Grunticon works. So as I mentioned, if Grunticon discovers this attribute, data Grunticon embed, it will replace whatever's inside that element with the inline SVG. So that means we can put anything we want inside that element, and then Grunticon will go and replace it later. So let me explain how all this works. If we go to gruntfile.js, you'll see here inside the grunt task, there are two things that happen. First, we run svg min, which minifies the SVGs, and this takes all the files inside development and graphics, runs svg min on them, and then outputs the minified SVGs in a new folder called svg optim. Then Grunticon runs on svg optim, so the optimized SVGs, and outputs all the SVGs and all the other information into production graphics. That means if I go to development, graphics, I will find a folder called svg optim that has the optimized version of all my SVGs. And that in turn means I can go and grab the logo file in its entirety, highlight all the code and copy it out, and then inline it into index.html where I want the logo to be displayed. Now this will look a little bit weird because we're now adding a ton of code into our page. You'll see what I mean if I toggle soft wrap here, that up at the top here, we now have the whole SVG. But the cool thing is this means the SVG will be displayed right off the bat, and then Grunticon will kick in and replace this code with its own generated code if necessary. The reason why I want to do it like this, even though it's kind of superfluous, is if the browser that's visiting the site does not support SVGs, Grunticon will go and replace this inline SVG with a PNG fallback, so you'll still see the logo. That's the real genius of this entire approach, and that's why I'm showing it to you. So now if I save index.html, what will happen is the page loads, we first see this inline SVG, and then once Grunticon kicks in, it'll replace the inline SVG with an inline SVG that's exactly the same, or with a fallback to a PNG. So it works perfectly, and it's optimized for performance. When you run Grunticon to create new SVGs or alter existing ones, just run the grunt process in the command line, drop the new SVGs or the altered SVGs into the graphics folder, and Grunticon does the rest. This is a prime example of how command line tools can make website optimization super simple. For a full rundown of how to use Grunticon for the display of SVGs, check out my course Web Icons with SVG, in particular Chapter 5 on Grunticon. As HTTP2 comes online, the way we optimize code for the web changes. Many of the best practices we used to swear by are still valid, but many others are now either pointless or counterproductive. In this chapter, we'll take a close look at not only how to optimize our code for HTTP2, but also how to optimize delivery of assets, and last but not least, how to optimize our process through command line tools. Before we roll on forward, let me point out some landmarks so we can get our bearing. First of all, minification is to code files what optimization is to image files. Just like it always was and just like it always will be, minified code files are physically smaller and require less bandwidth, so continue to minify all the things. Second, HTTP 2 allows for multiplexing. That means concatenating all your CSS and all your JavaScript into huge files becomes counterproductive. It's better to serve them up as individual modular files and take advantage of the caching options in the browser. Third, the order in which content loads in the browser matters, especially for perceived performance. We already know that CSS and JavaScript blocks rendering in the browser, so where possible, we should defer or delay these assets to allow the browser to render at least the above-the-fold content before getting bogged down. Fourth, browser manufacturers are as concerned about performance as we are and are doing a lot of work to improve things on their end. That means new performance best practices will come online sooner than you think, and your process needs to be agile enough to incorporate them. And finally, when it comes to performance optimization, command line tools are your friends. So, if you've been avoiding them until now, this is the time to jump in headfirst and immerse yourself. Just like in the previous chapter, I'm going to show you tools and techniques to improve your process, and everything I show you in my example project can be translated into your projects. So, grab the exercise files, pull them apart, and deploy what you learn in any way you like in your projects. Code minification can have a significant impact on the performance of a site, both for the individual user and for the server, especially if the site has a lot of traffic. If you think about it, shaving just 5 kilobytes off a page load that gets loaded maybe 1,000 times will save 5 megabytes in data transfer from the server. That's a significant performance improvement. And much of this can be done by simply minifying your HTML, your CSS, and your JavaScript. So what is minification? Well, if we go look at the output in the production folder right now, you'll see that everything is formatted for humans. There's a lot of space, there's a lot of indentation, there's a lot of line breaks to make it easy to read. We also have comments throughout the document to tell humans what exactly is going on. Well, none of this really matters for the browser. The browser just wants the code, and that means we can take away all the spaces, all the line breaks, all the comments, and crunch the file into one long line of code. It makes it completely unreadable for humans, and that is irrelevant because humans are not going to read this file. Humans will be working in the development folder, the computer works with the production folder. So we want to minify index.html, style-main.css and all of the styles, and any of our custom JavaScript files. You'll notice that the custom JavaScript files, flexslider.js and menu-toggle.js, are formatted for humans. But if we go into the libs folder, you'll see that these are already minified, so we don't have to do anything about them. Now, of course, when you look at these JavaScripts, you're like, well, you don't really have to minify these because they're tiny. But this is an example. In real applications, you'll usually have gigantic JavaScript files, and here, minification becomes really important. When it comes to code files, we need to use individual tools to minify the different types of files because different types of files require different types of minification. So in this movie, I'll show you how to use Gulp HTML min to minify HTML, Gulp minify to minify JavaScript, and CSS Nano, which is an extension of Pulse CSS to minify CSS. I've already installed all of these through npm on command line, so here you can see we have CSS Nano, we have Gulp HTML min, and we have Gulp minify already in package.json. That means all I need to do is set up my Gulp processes. Now, if you remember from the run-through of my Gulp file, I already have tasks set up for each of these types of files. I have an HTML task, a JavaScript task, and a CSS task. So now I just need to augment these so that I get the minification I want. As always, I need to first define the minification tools. So from the top here, I'll start with HTML min. HTML min equals require Gulp HTML min, comma. Then I'll go to my HTML task and set up HTML min. To do that, I first grab the HTML files. I've already done that. Then I set up a new pipe. In this pipe, I'll run HTML min. That's the function we just created. And inside HTML min, I can now set up a bunch of parameters. To find out what these parameters are, we first have to go to the HTML minifier documentation, because HTML min is just a Gulp version of HTML minifier. On the GitHub page, if you scroll down a bit, you'll find all the options that you can toggle on and off. So here you can really control exactly how you want your HTML to be minified. In my example, I already have this set up. So inside the curly brackets here, I'll first say collapse white space. This collapses white space. Then I'll say minify JS. Now this minifies the JavaScript inside the HTML file because there may be embedded JavaScript in the file. And finally, I'll say remove comments. So now this task grabs any HTML file, runs HTML min with these settings, and outputs it to the production folder. So let's see exactly how that works. If I go to index.html in the production folder right now, you can see we have a human readable version. If I save my Gulp file and go to the command prompt and run Gulp HTML, and then go back into index.html, you'll see now the index.html file has been minified. So it's no longer really human readable. As you can see, it's just a long, long list. And if I go and view this with soft wrap, it's just a big mess that's completely unreadable, but it still works just as well on the front end because we haven't actually changed anything. We just made the file a lot smaller. Next up, JavaScript. And here we'll use Gulp minify. Now the thing with JavaScript is in my development folder, you'll notice under JS, I have a subfolder called libs, and this is the folder that holds the libraries. Now these are already minified, so I don't have to do anything to them. The only thing I want to minify are the files that I created myself that are human readable. So in my Gulp file, if we scroll down to the JavaScript section, you'll see here I've split up the JavaScript task into two separate elements. We have the first one, which targets the JavaScript folder and any JavaScript files within it. This is the one I'll use to minify those files. And then we have a separate component that goes into the libs folder, grabs the JavaScript files, and just outputs them. So I only want to minify the first files here. Once again, I first need to queue up my minification tool. Here I'll set up a new one called minify, require, and this one is called Gulp minify. Then I scroll down to JavaScript. I grab the JavaScript files first, then set up a pipe for minify. And here I'll just run the function and then output the contents from the pipe into the destination folder and JS. Save that. Let's run that in the command line and see what happens. Gulp, JavaScript. And now when I go into the JavaScript folder, you'll see we have two new files, flexslider-min.js and menu-toggle-min.js. So these are the minified versions of flexslider.js and menu-toggle.js. And that also means to get this to work, I now have to go into my development index.html file and change the calls to these files so that we call the minified versions. The files are called here at the bottom. So here I have JS flexslider. I just need to say -min. And menu toggle -min. Save that. When I run the Gulp process, the index.html file will be updated in the production folder and everything will work. This leaves CSS. And here we'll use CSS Nano, which, as I said, clicks into post CSS. So once again, I'll go to Gulp file, scroll to the top first and call it in. CSS Nano equals require CSS Nano. Then I'll scroll down to the CSS task right here. And here you see we already have post CSS set up. Post CSS is currently running pre-CSS auto prefixer. And at the end of the chain, I'll now minify everything with CSS Nano. Save that. And I'm not even going to test this. I'm going to run the full Gulp process to see that everything still works. So in command line, I'll now clear the screen and then run Gulp. Now the entire process runs and I end up with a fully functional site again, meaning everything is working. And if I go back into Atom and look at production and style-main.css, you'll see now my style sheet is minified as well. So by using these three different NPM packages, I've now minified HTML, JavaScript, and CSS throughout the whole project. And in return for this work, I get optimized outputs for all these types of files. Now that we're working with HTTP2, we need to rethink how we're handling style sheets. In the old way of doing things, when we generated style sheets, we would take all the modules for the style sheet that we used Sass or pre-CSS or something else to generate, and then put them all into one single file so that we avoided blocking the load of the page. But the consequence of that is we would load in one gigantic CSS file that would have all the styles for all the possible modules and pages we might load up, all of it contained in one place. And that meant if we made one change to any of these modules, we'd have to reload the entire style sheet and invalidate all caches. And more importantly, we would load a ton of styles that were actually not used on the current page in question. Well, HTTP 2 solves that problem because we can now modularize our CSS and split it up into separate files and only load in the files we actually need for the page in question. And then those files can be cached on the server and in the browser so that we don't need to keep loading them up. That means we need to completely rethink how we've jigged our CSS, because right now, all the CSS gets generated into one single file, style-main.css. This happens through the Gulp process that grabs style-main.css, pulls in the CSS variables, then goes to the bottom of the document, finds the calls for the header, the menu, front page, promo, stories, footer, and flex slider, and bangs them all into this single file. So we get this one giant file called style-main.css. Now I want to remodularize my CSS and call in the different style sheets in a critical path on my page. To start that process, I'll take out all the calls to all these external style sheets on the bottom of style-main.css under development, and then call them in individually instead. Now I'm going to keep the call for the variables at the top here because I'm using variables inside this document, and I'll also have to call in the variables for my other individual modules as well. The modular files sit under the CSS folder, and right now they have this prefix of an underscore in front of them that's being used to say that this is a module rather than the full file. So I'll change the names of all these files except for variables to clearly indicate to me and anyone else that these are true CSS files that will be loaded on their own. All I'm doing is taking the underscore away from the front of the file name. Next, I need to take a look at how these files are split up because I need to make sure that I actually have the modules I need and that I don't have extra modules I don't need. For example, I currently have two files, one called header.css and one called menu.css. Now, in my case, in my site, the menu will always appear in the header. So it might be a good idea to combine these two. Now, this is up to you. You don't have to, but in my brain, it seems logical that something that will always be displayed together belongs in the same file. So I'm going to grab all the styles from menu.css, copy them out, and paste them into header.css at the very bottom. That means I can delete menu.css without any problems. Next, I have this promo file. Now, the promo is the stuff that happens here at the top of the page. Now, of course, you notice how everything looks terrible. That's because I just broke all my style sheets. So nothing is working the way it's supposed to here. That's fine. My style sheet is broken, but we can still see what's going on. Here we have this slider, and then we have this promo content. And this only happens on the front page. So that means I should be able to take the promo styles, copy them, put them into frontpage.css, and here I'm actually going to put them above the rest of the styles just to get the right order of things. And that means I can get rid of promo.css. Now I have the individual style sheet modules I want. However, some of these modules are using variables. You'll see here inside footer.css, I'm calling the variable beige, which is contained in the variables file. So to get this to work, I still need to run each of these files through pre-CSS and apply the variables. In style-main.css, I'm already calling in the variables up here, and we're going to do the exact same thing for all the files that may use variables. So I'll copy this out, go into footer.css, paste it in, and then change the call here to just variables, because the variables file is sitting in the same folder. Then I'll save footer, go to front page, do the same thing, go to header and do the same thing, and go to stories and do the same thing. This allows me to use the variables I've defined in all the different modularized files without having to concatenate them into one giant file. Of course, now that I've split these files up, I need to change the calls to the files in index.html so that I actually pull in the correct files. And this is where critical CSS loading comes in. Now that I've modularized my CSS, I can tell the browser in what order I want to load these different CSS files. First, I'm going to do this in the most rudimentary way possible, simply by calling them out in a list. And then in the next movie, I'll show you how we can defer some of the style sheets to delay loading of these style sheets to to make the whole loading of the page much quicker. In index.html, I'm currently only loading 2 style sheets, the styles for the web font from Google APIs and style main.css. So now I'm going to call in the additional style sheets as well in the order they appear on the page. So I'll start with style main because that's what contains the reset and the typography. Then we load up CSS header, which has the header and the menu. CSS flex slider, which has the boxed styles for the flex slider. These come from the flex slider library, so I'm not going to apply anything to them. CSS front page. This is the front page styles. CSS stories. These are the story elements that appear quite far down on the page. And finally, CSS footer. Now, the first time I saw this, I had the same reaction you're probably having right now, which is, whoa, that's a lot of style sheets to load at the head of the page. But the thing is, with HTTP 2, this is not a problem. All of these files will be loaded pretty much at the same time, and you won't have that issue of blocking content. In fact, the way some browsers load CSS now, as these style sheets load in, they'll start styling the page before the page is even fully loaded. We'll talk about that more later on in the course as well. Now that I've made all these changes, you're probably thinking, well, now you need to run the Gulp process again to make sure that everything is updated. Well, the thing is, Gulp process has been running the entire time and everything is up to date. And as you can see, the page is working fine with these new modularized style sheets. Don't believe me? Well, let's take a look at the markup. And here you see we have each of the style sheet modules individually being loaded. Why is this happening? Well, if we go to gulpfile.js and scroll down to the CSS task, you'll see the CSS task is just going into the development folder and looking at any folder with any file that is suffixed with CSS. So that means as I was changing these files, the Gulp task was running in the background and updating everything to make sure it works. In the end, I now have a fully modularized CSS setup that takes full advantage of the new properties in HTTP 2. In the previous movie, I showed you how we can take advantage of multiplexing in HTTP 2 to modularize our CSS and load the CSS up in a critical path at the top of the page. But here's the thing. My example is really simple. This is a very simple page. It doesn't have a lot of stuff on it. And you can imagine how if this was a really advanced page or application, doing this might cause problems simply because you'd throw so many style sheets at the browser. It would have trouble handling all of it and it might not load exactly right. Wouldn't it be great if we could somehow defer some of these styles to load later? So we could say, load the stuff at the top of the page, and then when the page is loaded completely, load in the stuff at the bottom of the page afterwards. Well, the thing is, we can do this with JavaScript. We can use async and we can use defer to literally defer the JavaScript until everything else is loaded. But there's no such function for CSS, unless we build one ourselves. In the exercise files for 0404, you will find a function to defer style sheets. So here's what we're going to do. We'll take the style sheets we don't need at the top of the page and defer them until the page is fully loaded. In my example, those style sheets are stories.css and footer.css. So I'll cut those out and then scroll to the bottom, and here you'll see the function in question. Here, I've added a custom JavaScript function I found on the web called load deferred styles. This function waits for the full page to load before it loads up the deferred styles and then forces the browser to apply those styles afterwards. And the way it works is you first add the script in its entirety. Then you add a noScript tag with the ID deferred styles and put in the link elements for each of the styles that you've deferred. If the browser supports JavaScript, the function will now load, grab the style sheets in the deferred styles ID element, and load them up after everything else is loaded. If for some reason the browser does not support JavaScript, we'll hit the noScript tag and these link elements will be loaded immediately, but they'll be loaded at the bottom of the page. Now that is a bit of a web standards crime. Well, not really, but at least in the old way of thinking it is. But this works way better than putting everything at the top. So by using this function verbatim in your project, you can automatically defer the styles you don't want to load immediately on your page. This can dramatically improve the perceived performance of your site, especially if you have a ton of CSS to be loaded that only affects stuff further down on your pages. So grab this code from your exercise files, plunk it into your projects, and see what happens. Okay, HTTP2 is cutting edge bordering on bleeding edge. Now I'm going to show you something that I would consider bleeding edge bordering on falling over the edge. This is a really, really cool thing that I sincerely hope will become the new standard for how we queue up style sheets. It doesn't really work all that well right now, but it's coming down the pipe, and if the browsers support it, it will be amazing. So in the two previous movies, we've been talking about making this critical loading path for CSS. So in the first movie, we just piled all the CSS modules at the top of the page. And in the previous movie, I showed you how you could defer some of these CSS files to the bottom of the page so that we get a better loading path. Well, wouldn't it be neat if we could add the style sheets to the modules themselves and say, hey, here's the header and here's the style sheet for the header. Then here's the flex slider and the style sheet for the flex slider. And here's the front page component with the front page. And then here's some other stuff with a separate style sheet. And then here's the footer and the footer styles. This is the crazy part. This might actually happen. Currently, work is being done on what's called link in body. And that means we take the link elements that point to style sheets and put them into the body element of the content. Now, the thing is, this is currently supported in browsers in a really rudimentary way, meaning if I take one of these link elements, cut it out, and put it in somewhere inside the body of my HTML page, the browser will just see the style sheet and go, oh, a style sheet, I'm going to wait until I've loaded this before I render the entire page. But the cool new feature that is being built into some browsers and might become a new standard is if you add one of these link elements inside the body and you put it inside an element like a header or a section or something else, then the browser will render that element with that style sheet before it renders anything else. So you don't have to wait for the entire page to load or all the style sheets to load before the page gets rendered. It gets rendered step by step. You can see a demo of this if you go to this article by Jake Archibald, and it's really cool, but like I said, it only works in some browsers. But as we're talking about HTTP2 and optimization and performance, you can imagine if we can append our style sheet link tags directly to the individual modules where they appear and have that load dynamically as the page is loading, we could dramatically improve in performance of content. And we can also totally modularize everything on the web. It means a widget could come with its own link element for its own style sheet. The footer could have its own style sheet that only gets called in if that particular footer is being used on the page. And you could even build this into content management systems like WordPress and Drupal and literally have each component bring its own style sheet. Like I said, bleeding edge bordering on falling over the edge, but this might very well be the next step in CSS loading thanks to HTTP2. We've talked a lot about CSS and how we can optimize performance for HTTP2, so now it's time to take a look at how HTTP2 impacts the way we load JavaScript and how we can improve performance by using async and defer. First of all, HTTP2 makes JavaScript concatenation pretty much unnecessary. You'll remember when a page loads in HTTP1, anytime the browser encounters a JavaScript, it stops rendering the page, then downloads the JavaScript file, then re-renders the page. And that means if you had a ton of different JavaScript files and you can only download 6 at a time, the JavaScript would stop the rendering of the page constantly. It would get what's known as head-of-line blocking. To combat this, we would concatenate all the JavaScript files into one huge file and then just download that one huge file all the time. But that became an issue because we just download tons of JavaScript you don't need, and these files are really huge sometimes. So in HTTP2, we can solve that issue entirely by using the multiplexing capability to load up individual JavaScript files when they are needed. That said, JavaScripts still belong at the bottom of the page, at least mostly. In the few cases where JavaScripts should be loaded at the top of the page, that will be well documented and explained, and there are very few cases where that's necessary. But you can actually see one of them in the example files for this project. The Grunticon JavaScript has to be loaded at the top in the head section. This is kind of non-standard, and it only happens for very specific types of JavaScript, as you will see in a second. Let's take a look at how JavaScripts are loaded by the browser if we do nothing. So here we have a standard script tag that just points at a JavaScript file, and we place it somewhere in our document. When the browser parses the page, it starts with the HTML and starts parsing it until it encounters the call for the JavaScript. Then it stops parsing the HTML while it downloads and then executes the JavaScript. Only after both the download and execution are complete does it continue parsing the HTML. And here you see why we usually place our JavaScripts at the bottom of the page, so we're not blocking the HTML parsing until the JavaScript kicks in. The other reason is, in many cases, the JavaScript will augment either the DOM or the CSS OM, or both, and that means they need to be fully parsed in the browser before the JavaScript can kick in. But we can change this behavior because, as you can see, there's a lot of dead space here where nothing is happening. If we append the async attribute to our script call, the way the browser parses the content changes. Now the browser will continue to parse the HTML while the JavaScript is downloading, and the only time the parsing stops is when the JavaScript is executed. So this improves the performance of the page quite dramatically. The problem with async is you don't really have control over when the JavaScript will be executed. So that means if you have a bunch of different scripts called in and they're all being called in asynchronously, they will just start executing once they're finished downloaded. And if you have dependencies, you may end up having a file execute before its dependency has been loaded in the page, and that will cause problems. The defer attribute kind of solves some of this, and it does it by completely deferring the execution of a JavaScript until everything else has happened. So we parse all the HTML, the JavaScript is downloaded whenever it's encountered, and the execution only happens once the entire HTML is fully parsed. The other thing to know about defer is when you use defer, the execution of the JavaScript will happen in the order the deferred elements are listed on the page. That means if you list a bunch of different elements with defer, they will execute from the top down. And that means you can tightly control when different elements are executed in the page, and you can preserve dependencies properly. Async and defer have always been useful when we've been loading JavaScript, but with HTTP 2 and multiplexing, it all of a sudden becomes far more important. So now the rule of thumb is you pretty much async any JavaScript unless you want total control over when it executes, in which case you defer it. So let's take a look at what that would look like in our example project. In my index.html file, I have some JavaScripts called in at the very bottom where they normally are. So if you scroll down, you can see them here. I have the jQuery library. I have Flex Slider. I have my own custom setup for Flex Slider. I have the menu toggle. And I have the flexibility library, which ensures backwards compatibility for Flexbox. Now, Flex Slider and menu toggle depend on jQuery. So that means I need to load jQuery before anything else. So I'm going to leave jQuery the way it is, no async, no defer. When it comes to Flex Slider and the Flex Slider custom code, I can choose to async them if I want to, just to continue loading the page. The menu toggle can also be asynced if I want to, because it doesn't really matter exactly when in the chain it loads, as long as it loads after the jQuery library. And finally, flexibility, I'm going to defer, because flexibility can only load once everything else is painted properly in the browser. Now, looking at this and knowing how the browser loads content using HTTPS, I'm sure you're thinking the same thing I've been thinking when I look at this, which is, it's quite possible we might be able to move some of this stuff to the top of the page and have it execute sooner. However, if you want to do that, you have to be very careful about what the JavaScripts actually do. For example, we know that the Flex Slider appears above the fold at the top of the page, and the temptation would be to queue up the Flex Slider scripts asynchronously at the top of the page. However, Flex Slider can't actually do anything until the DOM is loaded in the page and all the styles are loaded. Otherwise, the Flex Slider will be totally messed up. So therefore, even though we can technically load it at the top of the page, because of the script itself, it has to be loaded at the bottom. But other scripts might benefit from being loaded at the top, including the menu toggle and flexibility. This is entirely up to you, and you can kind of experiment with it in the browser and see what happens when you move these things around. But using async and defer in conjunction with the multiplexing in HTTP2 allows us to further optimize the way JavaScripts are loading without having all this head-of-line blocking and JavaScript blocking as the page loads. In the next chapter, I'll show you how we can trick the browser into loading up these files sooner and further improve performance. Optimizing your images and your code can go a long way to improving performance, but if you want to truly optimize your site, you need to take advantage of the performance feature offered by your server as well. Out of the box, most servers come with some performance tools already activated, while others are dormant or require individual customization on a site-by-site or page-by-page basis. In addition, HTTP2 introduces some new features that can be utilized to improve the performance of your site further, but they have to be deployed on a site-by-site and sometimes page-by-page basis. In this chapter, we'll take a closer look at how to take advantage of some of these performance features on your server and how to make the server do some of the heavy lifting for the browser. I'll also walk you through an intricate command line process to take full advantage of browser caching and give you an introduction to the revolutionary new HTTP2 tool called Server Push. So, time to compress our files, push them to the browser, and cache them for future use. GZIP compression allows us to compress pretty much all the files that are transferred from the server to the browser, and this has a dramatic impact on performance because smaller files take a shorter time and less data to load into the browser, and the browsers have become very good at unpacking gzipped files. To get gzip to work, you need to activate it on the server end, and that requires some server configuration. Now, there are a couple of different ways you can do this, and it all depends on your particular web host. On some hosts, you may be able to activate gzipping through the server-side application, something like cPanel. This is a SiteGround and their cPanel, and here under Advanced, I have Optimized Website. From here, I can either disable compression, I can compress all content, or I can provide specific MIME types I want to compress. So I can list what types of files that should be compressed. This is a server-wide setting, so this will apply to all my sites and all my content within this server installation. If you want to activate gzip for a specific site or a specific application, more and more you can do this through the application itself. WordPress, for example, has a ton of different plugins you can use that you simply activate and turn on, and then gzip will be applied to all the contents within WordPress. Joomla has similar features, and so does Drupal. However, in most cases, you may want to hard code the gzipping into the server configuration for your site. This gives you detailed control over everything, and you're not relying on an application to manage all this for you. In that case, we need to augment the server configurations, and this will change depending on what type of server you have. The cool thing is, all this code is available on the web, and you have a couple of different options here. The best source I've found for these configurations is the HTML5 boilerplate GitHub repo. In this repo, you find server configurations for Apache, Google App Engine, Internet Information Services, this is the Windows web server, Lightpod, Nginx, and Node.js. And if you go into each of these server configurations, you will find the compression settings for each of the servers. Now, to simplify things a little bit so you don't have to scrub through all the code, I've put these configurations in the exercise files for this movie, 0502. Here I have two example files for you, one for Apache and one for Nginx, which are the two most common web server applications out there. In Apache, you will set up an htaccess file, and notice that it starts with a punctuation mark, which is kind of weird, but that's how the server configuration works. Now, the htaccess file usually has a ton of content already, so you'll be augmenting the existing content. So what you would do here is cut and paste what you see in this file into your existing htaccess file. Now, for htaccess, I'm giving you two options. There's a simple version and a verbose version. The simple version comes from SiteGround. It's right here, and it basically compresses everything, and it also has fallbacks for older browsers that don't work properly or do weird things with compression. So if you want to use the SiteGround version, simply copy out this if module mod deflate all the way down to end if module. Basically, this compression here looks for HTML, CSS, JavaScript, and any other type of file except for image files and compresses everything. And all these fallbacks you see here are well documented. They basically address issues where browsers are either not gzipping properly or pretending to be other browsers, so the gzipping gets messed up. Now, this is, like I said, a plug-and-play simple solution. You just grab this, copy it, and paste it into htaccess, and off you go. If you want more detailed control, you can get the verbose version that comes from the HTML5 boilerplate. Here we're using if module mod filter and add output file by type deflate. And then we have a list of every possible file type we may want to compress. So the deflate function is actually the compression function. We're basically saying deflate the file, so make it much smaller. And then when it gets to the browser will reinflate the file. Using this verbose version, you can detail control exactly which types of files you want to compress. So here you can pick and choose from the huge list of files and just knock out whatever you don't want, and you end up with detailed control of compression. So if you're on an Apache server or on a server that supports the htaccess config file, then copy either the first simple gzip version or the verbose version. If you're on Nginx, you need to augment the Nginx conf file. And here again, you take the existing file and paste in the code you see here. Now, there's a good chance this code already exists in your config file, so make sure it's not there before you paste this in, otherwise things will get really weird. Nginx works quite differently. Here, you first say gzip on to toggle it on. Then you can set a compression level. You can set the gzip min length, that is how big the files are. You can compress the data for all clients or just some clients, and you can make some other changes. And in this example, like the verbose example for htaccess, here you have a list of all the different file types you may want to compress. So here you can pick and choose what you want to compress and also how much you want to compress it. The Nginx settings are a little more advanced than the Apache settings, and for good reason. Nginx is a much newer server protocol than Apache, and if you use this correctly, you can get an even bigger performance boost than you could on Apache. So, if you want to enable gzipping on your site, first check to see if you can enable it globally on your entire installation, which is probably a good idea. Then check if you can do it inside the application, like WordPress, Joomla, or Drupal. And if you can't do that, or if you want detailed control, use the code examples in the example files for this movie. Browser caching allows us to tell a browser for how long it should keep any single file it's downloaded. And for obvious reasons, this will result in dramatic performance improvements once you go through a site many times, maybe switch from page to page to page, or return to an existing page. Now, browser caching actually happens in the browser, and the only thing we can do is give the browser information about how long we want it to cache any specific file for. To see this in action, we can go to a live site on the web, and here I have the example of the HTTP2 site, space.morten.com, and if I go and inspect the elements here and switch to the network, I can see all the downloaded assets. Now, first I'm going to re-download this page with disable cache checked so that I get all new files downloaded. And then I can look at the headers for the file. You see, every file that's sent from the server has a header that has a bunch of information about that file. So if I select, let's say, style main here and just click on it, it opens a view where I can see the headers. And here you see the request URL, so this is where the file sits, the method, which is get, we got the file, status code 200, meaning it did actually exist and it got passed through. And then as I scroll down, I get the response headers. And here's what we're looking for. Cache control, max age, and then a number. So this number is in seconds, and it tells the browser this file should be held in the cache for a maximum 1 month. At that point, even if there's no new file, you should re-download the file again. So how do we pass this message to the browser, and how do we control which files have which messages? In the exercise files for this movie, 0503, I have an example of how we can do this in htaccess on an Apache server, and it's really straightforward. We simply set up files match, which just says any file that has the following suffix on it, and then we look for any file with the suffix CSS, JS, or ICO, and we set the header, cache control, to max age, and then a huge number, and public. This number is the seconds in a full year. So this means all CSS, JavaScript, and ICO files will be saved for a full year in the browser cache. Then we can set up a separate rule, files match, and here we have all the image extensions, JPEG, PNG, GIF, and SVG. And again, header, set cache control, max age, and this time I have the seconds for 1 month. So using this exact markup, we can now specify how long we want the browser to keep each individual file. Now in my case, because my site is a static HTML site, I might also want to set up a separate rule for the HTML page. And then I have to think, how long is it going to take before I might change that file? Because what happens when you cache a file is the browser will always use the cache file unless it gets another message. That means if, say, you update an HTML file and the original is still in the cache and the cache is not expired, then the browser will just recall the old file again. And the only way to get the new file to call up is to either change the file name or send a message to the browser to clear its cache, which is fairly complex. So when you set the max age for files, think about what happens with those files you're caching. How often are you going to update them, and which files are you going to update, and how are you going to manage that update process? Now, in the next movie, we'll look at how we can kind of override the caching process in the browser, even though we've set up long caches. So my recommendation generally is to cache files that are unlikely to change, like CSS, JavaScript, the ICO, which is the favicon, files like that, for a full year, and files that are more likely to change, like JPEGs and other images, or even the HTML file, to a max age of either a month or maybe a week. Experiment with these settings, put them onto a server, and see what they do. Caching assets in the visitor browser cache can dramatically improve the performance of your site after first load. However, there's an obvious problem. When we first load a page into our browser, all the necessary files are pulled off the server and placed in the browser cache. Now, some of these files may be marked for further caching. As you can see in this example, my style sheets and my JavaScript are marked to be cached for 1 year. That means the browser will not go looking for a new version of these files for a full year after the first time they are downloaded. What happens now is the next time you load the same site, maybe a month later, the only file that gets pulled over is index.html because it's not cached. The remaining files still have 11 months to go on the cache date. So what happens if we try to update some of our cached files? Let's say we updated style.css, menu.js, and accessibility.js. Well, when a visitor 2 months later comes to the site and downloads all the assets, we'll still download index.html because it's not cached, but when we try to download style, menu, and accessibility, they don't pass over because the browser cache has not expired yet. In other words, the visitor will not see these updates. Now, to fix this, one of two things need to happen. Either the visitor has to clear his or her own cache. This can be done in the browser settings, but very few people will do that. Or we have to change the server settings to invalidate previous caches and then push new files, which kind of counteracts the whole point of using caches to begin with. But there's a really clever solution to this, and it's called cache busting. We literally force the browser to download new files. And we can do this in a really smart way by simply renaming the files anytime we change them. Now, on the face of it, that sounds really complicated because we don't want to rename style.css to style version 1, style version 2, and so on. But we can use something called a file hash to do this. A file hash is a unique number that's generated from the contents of a file. And that means anytime you change a file, the file hash will change as well. And we can use some tools to append the file hash to the file name. And then anytime there's a change to the file gets a new name and will be brought into the browsers. So here's what that would look like. If I just generate file hashes for these different cached files, you'll see now we have style-1234556 and so on. These numbers at the end are the hashes, and they're auto-generated using a command line tool. Now, the first time I load the site, all the files are brought over into the browser cache and everything is set to 1 year expiration. If I update any of these files now, the file hashes change, and that means the browser will download the files because it goes, hey, I don't have that file, so I'm going to download the new file. And therefore, we bypass the whole issue of caches not updating. So now, even though we're using long expiry date caches, we can still transfer the new files over. Now, there's one caveat to this. Of course, this means that we're shoving new files into the browser cache. It will fill up the visitor's browser cache. But the browser caches are really smart, so they do ditch files if they're never used. So how does this work in real life? This is one of those perfect examples of how command line tools can come to the rescue. Because honestly, if you had to do this manually with all your files, it would be a total nightmare and you just wouldn't do it. Fortunately, we have tools to make this happen, but we have to use several different ones and string them together in a very specific way to get it to work automatically. The tools I'll be using are Gulp Rev. This tool automatically appends caches to the end of file names. Then we're going to use Gulp Rev Replace, which goes into index.html and any other HTML files or other files, finds references to the files that were just hashed and changes them so that we don't have to manually change these files. It's a really important step, otherwise the whole thing becomes completely unmaintainable. Third, we use revdel to go through the manifest and figure out which files are the currently updated versions and delete all the ones that are not, so we don't end up with a ton of different hashed versions of our files in our storage. In the exercise files for this movie, 0504, I've put all this together so you can see how it works. And this is kind of complicated, so I urge you to really check out what's happening here and maybe just copy some of this code into your own projects once you want them to work. As you can see, I've added the 3 functions here, Gulp Rev Replace, and revdel. I also set up a new variable called limbo, which has a folder called limbo, and you'll see in a second how this works. So the image optim function has not changed, but when we go down to HTML, JavaScript, and CSS, I've changed the destination of the optimized files to the limbo folder. The limbo folder will be used as a kind of placeholder until we rev the files. So HTML outputs its files to limbo, JavaScript outputs its files to limbo, and CSS outputs its files to limbo. Then we get the new functions, and there are actually 2 of them here. First, we have revision, which runs rev. Then we have rev replace, which goes into the HTML file and replaces everything. So here's how this works. In revision, we grab any file in limbo that has the extension JS or CSS. Then we run rev on these files, meaning we are appending the hashes to the end of the file name and place them into the destination folder. That's the production folder. Then we generate a manifest. The manifest is a JSON file that lists the original file name and the new file name with the hash, so therefore we can compare them. Then we use revdel to compare the original manifest with the new one and delete all the files that are not in the new manifest. And this will actually go through your production folder and remove any of the files we're no longer using. Finally, we print the manifest to the destination folder so we can use it the next time the process runs. Once all that's done, we run the rev replace task. This task grabs all your HTML files and runs rev replace on them using the manifest for reference. It looks for any instance of an original file name, say stylemain.css, and replaces it with the correct file name from the manifest. That means anytime you update a file and a new hash is generated, the HTML file will be updated to get the correct reference. You're always using the latest version of that file. All this stuff together makes this happen automatically. But now that I've strung everything together, you'll notice that each of these Gulp tasks has dependencies. So what I've done here is I've set up rev replace as the main function. But for rev replace to run, we first have to run revision. When we run revision, we first have to run HTML, CSS, and JavaScript. This is done because I need everything to run in a specific chain so that all the files are updated in the right order. So basically, anytime I make a change to the HTML files, CSS files, or JavaScript files, I want this entire stack to run. So when we scroll down to the watch tasks, you'll see I've changed the watch task. Now I only have 2. I have one that manages all the images. That has not changed. And then I've created a second watch that watches for any HTML, CSS, or JavaScript file. And anytime they change, I run rev replace, which runs revision, which runs HTML, CSS, and JavaScript. So it's kind of heavy-handed in that we are now running through all the files every time there's a change made, but it's because we need the file names to change, we need the HTML file to update, and we need the manifest to update so we can delete the old files so the whole project doesn't get cluttered. It also means I have to change the default task at the very bottom. You'll remember this is what runs when we just type in gulp in command line. So here I've taken away almost everything and just put in image optim, the images, rev replace, which runs the entire process, watch, so that we actually watch things, and finally we run the web server. So what does this look like? Well, I've set this up so I can demonstrate it for you. If we look at the folder structure right now, we have development, production. And if I open development and production, you'll see in production, we don't have the necessary files. I have the graphics folder and the images folder. That's because the graphics folder is generated by grunt and the images folder is generated by the image function here. I don't have the limbo folder, and I don't have CSS, JavaScript, or index.html in production. Now I'll run the entire task and you'll see how it all fits together. So I'll just say gulp, verbose, and run it. Now, the first time the web browser runs, it will probably run into a cannot get function because the HTML file has not been generated. But if you just reload the browser page, you'll see the page pop up as it's supposed to, and everything works. So that's cool on the front end. But if you look at the file structure, you'll see a lot has changed. Now we have a new folder called limbo. Inside limbo, we have the JavaScript and the CSS folders. And inside here, we just have the standard optimized versions of these files. So this is what we use to direct to the production folder. Then in the production folder, under CSS, you'll see that each of my files has a hash appended to it. So now it's flexslider-A226, blah, 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 blah. And the same goes for my JavaScript files and even for style main. And we also have a new file called revmanifest.json. If we open it, you'll see here we have the list of the old file names plus the new file names. So this is the function that replaces the URLs with the correct ones, so we always use the correct files. That's all cool, but the coolest part is how this runs once you make an update to anything. So let's say I want to make a change to the header. I want to change the background color here from blue to red. I'll go into CSS, in development, go to header, find the masthead, this is the top, and then just change this from navy to red. Now, I'm not going to save just yet because I want to show you exactly what happens. Pay close attention to the file here, the one that's called header 126370ebf8. When I save header.css, the entire Gulp process will run, and this file will be replaced with a new one, and the new one will be added into the HTML file, and all of that will be displayed on the front end in the browser. So I'll hit save. You may have noticed that there was a slight glitch here as the old file was removed. And now you see header 0D5677, etc., has been placed where the old header used to be. And if I go back to the browser, I now have a red header instead. I can go back and change this back, save, and the file changes again. So with this new setup that has revision and rev replace, we are able to cache bust any browser that visits the site, keep everything up to date, and because we are using multiplexing thanks to HTTP2, we're only updating individual small files rather than all the JavaScript or all the CSS. So all this becomes way more performant for the user. Apart from multiplexing, server push may be the greatest advancement in HTTP2 where performance is concerned. Server push is exactly what it sounds like. We can tell the server to push content to the browser before the browser makes a request for it. So for example, when we request an HTML page, and in that page there will be calls to style sheets or JavaScript or images or something else, we can have the server push that content into the browser cache before the request is made. So once the browser renders the HTML and finds the reference to the file, it's already sitting in the cache waiting for it. In standard communication between the browser and the browser first makes a request to the server for the HTML page. The HTML page is sent back to the browser by the server, and then the browser starts to render it. Then the browser encounters a call to a style sheet. So it goes back to the server to request the style sheet. The server responds by sending the style sheet back. We continue rendering the HTML, then we encounter a JavaScript. So we go back to the server, request a JavaScript, it gets sent back to the browser, and so on and so on and so on. This is a long and tedious process, and it results in poor performance, and in particular, it results in poor perceived performance. So with server push, this all changes because once the browser sends a request to the server responds with the HTML file, but at the same time, it sends down a bunch of other files that have been specified as related to this HTML file. And while that happens, the browser is rendering the HTML and making other requests. So we are reducing the length of time it takes to send all these requests. We are also reducing the number of times you have to go back and forth between the browser and the server. And we are utilizing the browser cache as a storage point for files that may be used in the future. Now, of course, we can do this with CSS and JavaScript and images or any other related files, but you can also do this with other entire pages. So for example, if you make a site and you are certain that after reading the first page, someone will go to the next page, you can use server push to push the next page to the browser in advance. So once the person who's visiting the site clicks on the next button, the next page just instantly loads because it's already sitting in the browser waiting for the user. Now, when I say this, this is also the caveat. We can use server push to push whatever we want to the browser, but you should be a little bit careful about what you're pushing because it's not a good idea to just cram the browser full of every possible thing you can imagine. You have to be selective about what you're doing because you are using bandwidth the entire time you are pushing content. And if you push too much content, you slow down the communication between the server and the browser. In practical terms, server push is a new header on the main page that you are downloading. The best way to explain this is to just show you how it works on a live page. So here we have the example site running on HTTP 2 on my server. If I go and inspect this page, go to network, reload to get all the assets, and click on the main domain, I get the main header for the entire site. And if I scroll down here a bit, you'll see there's this header here under response headers that's called link. And within the link header, we have links to a bunch of assets. So here we have links to the Google Fonts archive for the fonts we're using that's set up with a relationship to preload and is set up as a style. Then we have a link to style main.css, again, preload as style, header.css, preload as style, the jQuery library on Google's server, preload as script, and we also have a call to an image. This is the first image in the slider at the top of the page, relationship, preload as image. So this section here, link, is server push. We're pushing all of these files to the browser in advance and storing them thanks to this preload relationship. You can actually see the result of this push in the network timeline. After loading the main page, we immediately load the pushed elements, including the Google fonts, a flex slider, the main style sheet, the welcome image, and header.css. These are the elements that are pushed before the browser even starts rendering, and then they get stored in the browser cache. Now, how did I pick these particular elements? Well, I looked at my page and I looked at what's above the fold, and then I figured what I want to do is serve up what's above the fold as quickly as possible. So I give the browser the components it needs to make that happen. That includes the main style sheet, the header style sheet, the JavaScript for the slider, and the first image in the slider, so we don't have to wait for all the images to load up. And then on the back end, I made some jigging in the code so that the first image will actually show up in the slider before the slider activates. So we're seeing an image, and then once the slider comes online, it'll pop in and replace the image. Now, of course, the next thing you're wondering is, how exactly do I get this link element into the header? Well, you can do this in a couple of different ways. Some hosts allow you to go into the hosting application and specify which files you want to push to a specific site. You can imagine that can get really tiresome if you're doing it on a large site or something run by a CMS. You can also go into the host configuration file, like the htaccess file, and just define the header, so header set link, and then just put in the actual code you want. This also gets really tedious, especially if you want to push different assets depending on where you are, because then you have to make a ton of conditionals within the server configuration file. It'll also slow down your server tremendously. The most effective way of doing this is to put the code into the documents themselves. Now, this means you can no longer run just straight up HTML files because HTML files don't actually do anything on the server. So what I've done here is swapped out my index.html file for push.php. It's actually the exact same file we've been working with all along. The only difference is I've added this PHP section at the very top. This PHP section consists of a function that I called push2browser that has two variables, as and URI. Then we set up a header and then the actual output. So here we have link and then the URI, relationship preload, as, and then whatever definition this is. Then I have an array that's called assets that has the actual link and the type of content it is. So link, style, script, and image. And finally, I use array walk to walk through the array and run push2browser on each of them. The end result is exactly what you saw in the browser. We get the link element in the header, and we can push all these pieces. Now, when you see this, you should immediately see why this is so powerful. If you are using a content management system like WordPress, or you are running Node on your server or anything else, you can add this type of code to the top of your pages and have the server push the relevant data to the visitor as they're loading different pages. You can make this all dynamic using whatever application language the server is running and your site is using. This is a PHP example, and as you can see, it's really straightforward. You have similar examples for JavaScript and .NET and whatever other application language you want to use. Now that you see what you can do, I'm sure you want to push everything. So here are some good best practices for server push. First of all, push whatever's above the fold. So CSS, JavaScript, and images that happen to be above the fold when the page is loaded. This will increase perceived performance of your site without really taxing the server. Second, push external assets, things like font libraries or JavaScript libraries that come from external sources, because these already exist somewhere else and you're going to have to make a request to those servers. You might as well do it immediately upon page load. Usually, these are also something that everything else on the page relies on, so calling them in early will improve the performance of the site. And finally, if you have next step pages that you know every user will go to, you can push these pages so that they're stored in the cache and will pop up immediately. But do this carefully because you don't always know what your visitors are doing. So try to test what works for you, but use server push strategically and you'll have tremendous performance improvements. To further optimize the performance of your site, you can and should use a content delivery network. Content delivery networks, or CDNs, cache the static assets on your site and distribute them across servers that are placed all over the world. Then, when someone visits your site, they're actually visiting the servers from the CDN, not your server, and pulling content from the CDN servers into their computer. This dramatically improves performance because the CDN servers are likely to be closer to the user, are likely to be more powerful, and are likely to have much bigger bandwidth than what you have on your own server. Without a CDN, when a visitor goes to your site, they're actually requesting data directly from your server, and your server will send that data up through whatever connection it has to the visitor. There are some obvious issues with this. First of all, the distance between the server and the visitor has a huge role to play in performance. If the visitor is in Eastern Europe and your server is in the United States, then every piece of data has to travel across the Atlantic to get to the visitor, and that will just take a lot of time. Secondly, if there are a lot of visitors to your server will have a hard time providing the files because it needs to use a lot of resources. It will also have a limit on bandwidth, how much data it can actually push through the network at once. And the more visitors you get, the more likely it is for your site to either slow down or break down completely. If you're using a shared host, you also have to consider the other traffic on the network. You would typically be in a server with many other sites, and if one of the other sites is very popular, then your site will slow down. And finally, you have your server performance. If you're using a cheap service provider, then your server will probably be cheap, and it won't perform very well, especially under a lot of load. There's also the issue of malicious attacks. If you set up a server on the web, there's a good likelihood at some point someone will try to find out if your server is vulnerable, and they'll try to send out spam to it or hack into it or attack it with what's known as a denial of service attack, where they just get a ton of computers to ping your server all at once to take it off the internet. With a single server, this is really hard to protect against, and the typical result of one of these attacks is your service provider will discontinue your service and take your site off the internet. When we use a CDN, all of this changes completely. Your server is only there to serve content to the CDN, and the visitor gets their content directly from the CDN. That means the load on your server dramatically decreases, and the CDN takes over the heavy lifting of feeding all the static content to the visitor. In addition, CDNs typically have solid security features in place. So if someone tries to maliciously attack your site, they're not actually getting to your server, they're trying to attack the CDN itself, and the CDN will have a firewall and other measures in place to prevent those attacks from actually hitting the files themselves. This will protect both your server, your data, and the visitors that are coming to your site. So in effect, using a CDN, you're offloading the responsibility of your data to a much larger network of computers that's far more suited to actually serve that data to the visitors. And of course, there is the global reach factor. If you have a server anywhere, there is a chance that you have visitors from somewhere else on the globe. CDNs were originally created to serve up data from large providers like TV networks or very, very popular sites. And they were created because these sites were having trouble serving all this data across the entire planet. Now everyone can take advantage of the same technology, and it's not very expensive. And the result is your site doesn't just live on the origin server, it lives everywhere in the world, and any update on your origin server gets pushed out to all the servers across the world. Now that I got you interested in using a CDN, I unfortunately can't tell you which one to use. That's because there are so many different options and they all provide slightly different features. Instead, I'll tell you how to pick the right one. If you want a solid CDN, here's a good checklist to follow. First of all, it must support HTTPS and HTTP2 with all the features, including server push. Not every CDN supports HTTPS, and not every CDN that supports HTTP2 also supports server push. So make sure this is a CDN that provides all the latest features, otherwise you won't get the benefit of all the stuff we've been talking about so far in the course. Second, ask the CDN about their global reach and find out where their servers are. Some CDNs only have servers in the United States or in North America, while others have servers all over the world. And it's important to match your CDN choice with the audience you have. If your audience is primarily in North America, then you can go with a CDN with servers only here. If your audience is worldwide, then you have to make sure you have proper coverage. Also ask about security features. Most CDNs will provide a firewall and some DDoS protection, but it's a good idea to check what you are getting before you buy it, because the better protection you can get, the better your site is protected and the better your visitors are protected. Of course, cost is a factor. The good news is most CDNs provide fairly cheap solutions now. You can get it from all the way down to $10 to $20 a month, but this all depends on the type of traffic you have, the type of security features you need, and how big your site is. So check the cost of a few different options and find one that fits within your budget. Finally, take the CDN for a spin to see how easy it is to use. Different CDNs target different markets, so some are more enterprise-focused and quite complex, but give you a lot of detail control, while others are more consumer-focused and very simple, but give you very little control. So here it's important to pick a CDN that fits with your specific usage scenario for each individual site you're working with. Now here's a caveat. Most hosting companies will claim to have CDNs, but they're really just a bunch of large servers that they're distributing your content over. To get the full benefit out of a CDN, you need to use a third-party CDN that only provides CDN services and nothing else. It will greatly impact your performance, and it'll probably also save you a lot of money in hosting costs. To that end, most hosting companies have CDN providers they collaborate with for one-click installs or few-click installs. If this is an option, check out how much money you'll save by using that bundled option, because usually they come with a deal. And also check out if there are any limitations or any weird funkiness going on in the setup to make sure you're getting the service you want and need. Finally, and this is really important, use a for-pay provider. There are free options for CDNs out there, but they are all suboptimal. In particular, most free options do not give you HTTPS support, which means you won't have HTTP2. To get the full benefit out of a CDN, you need to pay for it, and you should pay for it. So make sure CDNs are part of your overall budget for the site. You know, it's funny. Every time I come to the end of one of my courses, I wonder what would be the optimal way to wrap this up, and I usually come up short. I used to love how old cartoons would end with a page that said prominently, "The End," or "Fin," or something like that, making it absolutely clear that this was in fact the end. But that doesn't quite fit here, because when it comes to performance optimization, there really is no end. This is a moving target, and everything keeps changing all the time. Why am I going on about this? Because optimization and performance is as individualized as how you make an end to a video course. The tools and techniques I've showcased here in this course all have the potential to improve the performance of your sites, but how exactly you deploy them will depend on your particular projects. In some cases, performance trumps everything and you can go all out. In others, there are other factors at play and you may want to scale your performance optimization back a bit. And don't even get me started on process and workflow. How and where performance optimization fits into your process or that of your team will vary greatly. The good news is the tools and techniques can fit into any process. You just have to find the right fit for you and your project, just like I have to find the right ending for each of my courses. So, how about this? HTTP2 is, in a small way, what the philosopher Thomas Kuhn referred to as a paradigm shift. The way we used to do things in HTTP 1.1 no longer make any sense, but many of us are so used to doing them a certain way, we need time to rejig our processes, and in some cases, we simply won't. This course was made to give you a leg up in this development and get you started thinking in the HTTP2 way. As the new protocol takes hold and becomes more prevalent, new techniques and best practices will be introduced, and I will update this course to keep you informed. That way, you can stay on the leading edge of the brave new world of performance optimization. In the meantime, take the time to really immerse yourself in web standards, how to use command line tools, and explore the weird and wonderful world of server configuration. Web design and development is no longer confined to the IDE or the WYSIWYG editor. To take full advantage of everything our field has to offer, we must learn to talk to terminals and make servers do our bidding. HTTP 2 gives us many of the tools we've always dreamed of. Now it's up to us to use them to build a safer and more performant web. And all that's left for me to say is lykke til, thank you for watching, and I'll see you in the next course.